Okay, today we're talking about similar triangles. Okay? Now, two triangles or any shape are similar if they're the same shape but a different size. So I have two examples here of similar but not congruent. They're the same shape, they're both people, right? But are they the same size? No. Not the same size. Okay? They both have arms. They both have a head and legs. Same shape, right? But they're a different what? Size. Caroline's almost as tall as me. And Brittany's not almost as tall as me. So they're the same shape, but a different size, right? Which makes them similar. Okay, have a seat. Thank you. Now this symbol right here, this little squiggly symbol means what? This thing means similar. So the way I would have said Brittany and Caroline are similar is I said Brittany is similar to Caroline. But they're not congruent, are they? No. So now we've got two triangles here that are similar. They're not congruent, are they? They're the same size, same shape, but a different size. Now, because they're similar, we know they're proportional. Okay? Now, in 8th grade math, we learned similar, but we didn't relate that to proportional. And here, we're going to say they're similar. Therefore, we're going to be able to find the value of x using a proportion. Okay? So what proportion can we use here to find x? Can we say this over this? Because don't these correspond? This over this equals this over this. So tell me what to write. No, 10 over 5 equals x over 12. Now remember, we used 10 first, right? We said 10 over 5. So could we have said equals 12 over x? No, if you use something from this triangle first, you've got to use the other part from this triangle first.
If you had done 5 over 10?
Now, if you had done 5 over 10, you'd have to say 12 over x, but you got the same answer. Now, once we get to here, we have to do what? Cross multiply. So I've got 10 times 12 is 120, and that equals 5 times x, which equals 5x. Now I'm going to divide 5 on both sides. So what's 120 divided by 5? 24. So x equals 24. So using those three distances, we found out that this distance is 24. So since the two triangles we know were similar, we can find out what the fourth side was. Alright, so now we have triangle ABC, which is right here. And they tell you it's similar to triangle DEF, which is right there. Okay? Use the two triangles to solve each of the following. They want you to find B, and then they tell you all the rest. Okay? So what's E? So let's write over here 4. And what's A? 9. And what's D? D is 12. So since we know the two triangles are similar, we can set up a proportion. So I'm going to say 4 over B. No, what do they want? Yeah, B. 4 over B equals what? 12 over 9. It has to be 12 over 9. It can't be 9 over 12. We used 1 from here first, so we got to use 1 from here first on the second fraction. So we say 12 over 9. So now we can what? So I've got 9 times 4 by cross multiplying is 36. Now why can I cross multiply? Because my two fractions are equal. 12 times B over here, divide 12 on both sides. So what's B equal? B equals 3. So I go over here and I write B equals 3. So hold on, you just learned how to solve for a side of a triangle